Okay, so welcome everybody, and sorry for the little time that it took to share the screen in the right way. So welcome to this webinar. We are going to present a few techniques that we have seen in the past weeks that are commonly used to visualize the spread of the COVID-19 pandemic. So before we start, please use the Q&A section, the one that you see under the slides, to post your questions, and then you need to upvote your favorite questions so that we have a priority list of questions to answer. The session is recorded, so don't worry, and you will find it on YouTube. And then if you want to download the slides, if you want to have them, that's the tiny URL link for the slide download. Okay, so I'm not going to talk about the COVID-19 because we all know the situation, and we have all seen and heard much and more about the whole pandemic, so I'm not going to talk about that. However, in the kind of obsessive checking and looking for news and monitoring the situation, I have seen a few interesting visualizations that have been commonly adopted to communicate the situation. So to communicate the situation to the people, to communicate the situation to the politicians. So those are relatively powerful visualizations that I've seen going around on the internet. So in particular, I'm going to refer to these three sources. You can see on the coronavirus, the Why You Must Act Now is a blog post on Medium that at the beginning of the pandemic was very popular because it was offering a lot of visualizations to monitor the situation. Then there is an article by the BBC News, and this article proposes this heat map just to have a timeline to see what happened in the different countries since the beginning of the pandemic. And then the last one appeared on the Twitter account of Mark Henley. So at the very beginning in March, there was this idea that some countries could feel safe because the pandemic hadn't yet started in that country. And Mark Henley showed via this new plot that actually the effect was just delayed. They were late in the starting in the onset of the curve of the confirmed cases rather than immune. And so that was another interesting and powerful visualization. So just a few words about the data set that we will use. The data set is the data repository by the Johns Hopkins University. You can find it on GitHub, so you can connect there and get the data, I think, by the hour. The REST API, there is also on GitHub, there is also a REST API, and the REST API, with this REST API, you can connect to the data repository and then update your application. About the countries and areas and geographical regions that we have used in the next presentation, those are referred to those are what has been defined by the United Nations Statistics Division, so we haven't made them up. Okay, so let's start with the current situation. Everybody knows this curve. This curve is the shows the start in the China period, and then you can see this little bump after the China period. That's when the China curve started flattening. After that, the Italy period started when the contagion was somehow contained in Asia, and it started in Europe, and Italy was the first country that was affected by the COVID-19 spread. And then after that, all the other countries started one after the other, and then you can see that the curve becomes much steeper, and that's when the pandemic all over the world, I guess, can be said to have started. On the right, on the left, you can see the choropleth on the world map, and you can see it goes from a white 0 to the highest number, which is around, now it's around 300, and 300,000. And then you can see those are the number of confirmed cases, total confirmed cases in the country, and you can see that the United States at the moment are the ones with the highest number of confirmed cases. Let's split the problem by continent. So let's move first to Asia. In Asia, you can see the highest curve is China, and then you can see it started very early, it grew, and after the spread was, after the containment measures were implemented, the curve started flattening. You can see that the maximum reach was 80,000, around 80,000 confirmed cases in total. In the lower part, you can see the South Korea's curve, the red one, and the South Korea's curve is similar to the China's curve, of course, on a smaller scale, also given the smaller size of the population in South Korea. But what's important is that it started growing, and then again, due to the containment measures, the curve flattened up. The other two big curves are Iran and Turkey, and at the moment there, you don't see any flattening sign. Let's move now to Europe. In Europe, the pandemic is still raging. You can see all the countries there, they have a very steep growing curve. This is still the number of confirmed, the total number of confirmed cases by country, and on the x-axis, you have the date. Italy was the first one that started with the number of confirmed cases, with the spread of the virus, and implemented containment measures at the beginning of March. It's now slowing down. You can see the orange curve. It's now slowing down, but very slowly. There is not the effect that we have seen for China. And in the meantime, Spain, the blue line, is competing with Italy to have the highest total number of confirmed cases, and Germany and France come immediately after. So they are the highest, the countries with the highest number of total confirmed cases. After that, we have the United Kingdom and then Switzerland. Switzerland, if you don't see, because it's confused with all the other countries. So even though it's in the top 6, you can see that you can think that it has actually a very small spread, yet a very slow spread of the epidemics. So let's move again. Let's go to North America. In North America, you can see that the steepest curve belongs to the US. The second steepest curve is Canada, but it's much, much, much smaller. The US has now reached the 350,000 number of confirmed cases, total number of confirmed cases. And so it's, it's pretty aggressive. The contagion is going on there, is pretty aggressive. So when you have a plot like that, the steep curve of one of the countries doesn't allow you to see in detail what happens in the other countries. For example, we see that in Canada there are some cases, but we frankly don't see the trend. We don't know if it's flattening up, if it's, I mean, we can see barely, but we don't really see the details of the trend of the spread in Canada. So one best practice that is performed, it's implemented when there is this kind of situation, is to pass from a linear scale to a logarithmic scale. When you move to a logarithmic scale, you preserve the trend, because logarithm is a monotonic transformation, but the distances between the numbers are, of course, made much smaller. So you can still see the trend in much bigger details also for the smaller numbers. So we can see that Canada has a similar trend to North America, as much as the spread of the virus is concerned, even though the absolute numbers are definitely much smaller. Now, could it be that the absolute numbers in Canada are due to the difference in population density? I mean, Canada has the population size in Canada is much smaller than the population size in North America. So another common approach to visualize data by country is to normalize by the number by the number of the country population, to normalize by the country population. So in this case, we are going to get, instead of having the absolute total number of confirmed cases, we would have the number of confirmed cases per 10,000 inhabitants. So if you see now, we have a similar plot. The curve of the confirmed cases for the US is still the steepest one. But now you can see that Canada's curve is also not that small, but it's actually, it reaches a few cases per 10,000 inhabitants, so around 5 or 6. While the US, they are a little above 10 cases per 10,000 inhabitants. And then on the right, you can see the choropleth of North America, where you can see that the differences now between the Canada and the US is not that big anymore if we consider the normalized curve by country population. Let's see Europe now. So you remember, in Europe there was the highest curve were Spain and Italy. If we normalize, and you remember, then there was France, Germany, and then there was United Kingdom and Switzerland. If we normalize by population size, so if we check the number of confirmed cases per 10,000 inhabitants, then we can see that Switzerland is actually going much higher in the scale of the worrisome countries. So you can see, for example, that Switzerland has around 25 cases per 10,000 inhabitants, and Italy, for example, which has the highest number of cases, has a very similar number of cases if we consider the normalized numbers. So sometimes normalizing gives a better measure of how aggressively the virus is spreading in the country, even though the absolute numbers don't seem to tell so, just because the population size is not that big. Okay, and now we have here the another common numbers that I've seen around a lot in the past few weeks. The daily number of new confirmed cases. This is another measure of how aggressively the virus is spreading. So the whole idea is, I don't know if you have heard that, but there is, so how often, how many days it takes before the number of confirmed cases doubles, something like that. So of course, the steeper the curve, the smaller the time to reach the double number of confirmed cases. So this daily number of new confirmed cases is used to measure the aggressivity of the virus spread per country and whether the containment measures are working. So for example, if you see this video, okay, here you can see that in the US, the daily number of new confirmed cases has been growing quite a lot. That's the dark blue bars. Italy, it's the dark orange, has remained relatively constant in the last few days, even though it's not decreasing much. And then we have the Spain for the light blue, which is also growing, but at a less rate, at a smaller rate than the US. And then you have the other countries. So for example, you can see Germany, and then you can see France. They are also where the daily number of new confirmed cases has been also increasing in the last few days, right? Right, and this is France. France on the 4th of April had a big jump in the number of confirmed cases. Notice that there is in this bar chart that you don't see at the moment because they are sorted by the countries with the highest number of confirmed cases by daily. So you don't see in this chart the China and South Korea. That's because due to the containment measures that they've taken now, they have a much smaller daily number of new confirmed cases. And this is the plot that Mark Handley showed on Twitter, where he showed the number of confirmed cases per country, and instead of considering the x-axis as just the normal times with the normal dates, he considered the onset of the pandemic as the time zero. So the time zero is the onset of the pandemic for each country. So at the end, they were all brought, the curves are all brought together as if the pandemic had started at the same time in each country. If you do that, then you can see how the trend is growing for each one of these country. And then you can see exactly for the US, for Spain, Italy, and you can see that actually Spain has a much more aggressive growth than Italy, while Germany is really moving at the same rate as the spread of the virus was moving in Italy. So this is a curve that so it can be used to learn from previous experience. If your trend is steeper or the same as the trend of previously affected country, that's where you can learn how you can when you can start to intervene. And then finally, we have the heat map. This one was taken from the BBC article. This heat map from white to red shows the whole start of the pandemic. So here you have the time, and here you have the most affected countries. And then you can see that China is the one where is the country where it all started, and you know, the daily number of new confirmed cases was higher at the beginning. Then you have Japan. The absolute numbers were a bit more smaller than for China, and then South Korea, and then you can see Italy, and then you can see all the other countries one after the other. So this is also interesting to show how the pandemic has moved geographically and time-wise. Okay, Paolo, you want to show now how the workflow that you have used to perform?
Yeah, let me share the screen so I can now share the entire screen. Hang on, and switch to presentation mode. Here we are. Can you see my screen, Rosaria? Yeah?
Yeah.
Okay, great. So let's start. So let's see now how we can then have an easy way to create all those visualizations, right? How we set up something that we call GAN Analytics application. And to tell you right away what this means, I made this little video. You can see here a user interface. There is an overview with the total number of confirmed cases. You have the line plots, and then you have all those controls that you can select. For example, we can say the type of cases, disease of confirmed, the country, whether we want to use normalization or not. Then we can click next, and depending on the selection we did, the right charts, in this case normalized for Europe, on disease cases, they visualize, and we also have the map. Right? How do we create such an interactive application? So that's what I want to talk to you about. And as you might expect, we use KNIME, right? So for the ones of you that do not know what KNIME is, KNIME, we are using here the KNIME Analytics platform, which is a free and open source tool that you can use to do lots of different type of data science, of data manipulation. So all the way from data access to the analytics tools, and then to the deployment part. So it's all free and open source. You can go at that link to download it, and there are a number of extensions that you install with KNIME. All the extensions that we provide are free and open source, and then there are also the community ones that and the partner ones that are coming from third parties that also provide their extensions. So everything in a single tool. And this is also the part where you can understand how does actually KNIME works, right? It's about nodes. You have a sequence of nodes that does each node does a fundamental task, and when you put them in a sequence, you have your data flow that goes from data access all the way to your analysis. In this case, we have a small workflow. We are reading Excel. We are coloring some data. We are using partitioning to divide between train and test. And then we have a decision tree. We train one and we predict. And then we have also those light blue nodes to create the visualizations, right? So by using a sequence of nodes, you have a transparent way to analyze your data. Okay, so something else that also it's really important to understand how we create that application, it's called components. So basically we can package a sequence of nodes in a component. So the component looks just like a node, but inside you can find more nodes, and they can create complex views, and the KNIME user can really decide what is the complexity that this component is doing. And using over 3,000 nodes, you can do really any kind of component. So you can use KNIME in combination with other tools, depending whether you're also using another platform, you're using, for example, a tool for reporting and visualization, you are coding now in Python, or you have a big data platform you want to connect with. KNIME can mix and match those technology as needed. So that's also part of, that's for each of those integrations, we have different nodes. So you can have a look whether how you can combine KNIME with your tool. So now let's go back to the topic of data visualization. This is how KNIME looks like, right? That's maybe an easier way to understand how the KNIME Analytics platform looks like. We have here the KNIME Explorer, that is where you have your local workspace and also a way to access to our example server with more workflows, and the KNIME Hub, where also the community, you can share with the community your workflows and save them in the cloud. In the KNIME Explorer is where you save your workflows and your data, and it's a way to access all your workflows. Then we have the Nodex repository. Here we have all the nodes that we use within KNIME. And here in the middle, we are now seeing the welcome page, but when you open a workflow, it looks like this. And right now, actually, this KNIME Analytics platform, the screenshot is showing when we open the workflow that we have used to visualize the COVID data. So we have a GET request node to access the API data. We, in here in this meta node, we are transforming data from JSON to a simple table. Then we are joining the data from the United Nations Statistics Division. We are joining the data so that we get the continents, the population number. We perform with this math formula node the normalization. We convert to date and time, and then we actually are going to find missing values. So this is all data manipulation, and those two last components are actually how we visualize the data. Right? How we are going to create those two web pages with those different controls on them. Before I show you how those looks like, it's important also to tell that this workflow is accessible for any of you. So you can download it, and then when you open it on your browser, you can, for example, re-execute it. That's how it will look like. You can use these commands on the top to re-execute the workflow and get the latest data. And of course, you can customize it. You can add any node you want. So from the node repository, you, for example, select a table view, and then you drag and drop the node, and then you connect it. And once you do so, you can, for example, write some annotation of what this node does. It's a simple JavaScript table, and then you can execute the node, and this browser will come up with this simple table showing the output of the transformation from JSON to table, right? So this is just an example on how it looks like when you actually open the workflow and you customize it and you start executing. So where can you find the workflow to do these sort of things? You can find it on the app. You just go on app.9.com, which you can see up here, and then you can type in there COVID, and you will have a search engine, and this workflow page will come up. And actually, that's where I shared the workflow to the community on my space. Anyone can share workflows like this. And that's actually how all of this started. I was thinking, why don't we visualize the COVID data with KNIME, right? And then I decided to share with the community, and at the end, it was enough material to do this webinar. You can find this link also once you download the slides. So let's talk more about how we use those components here at the real part of the visualization is within those components. So what are those components? So components are created when you select a sequence of nodes, you select them all, and then you right-click on them, and then you select Create Component. And what you will see is a component being created. This is a light gray node with already some styling here of this symbol with a blue background. But in the end, that's how it looks. You basically have collapsed all those nodes within this component. And this is in order to create a piece of workflows packaged in a way that it behaves like a node. And regarding all the information that you want to give along the component, there is this node description panel from which you can add symbol, add colors, and beautify it and style it. Also the metadata, the description, what it does, and it's also something you can do. But once this component is created, you also want to make it robust. You want to make it in a way that can be controlled, right? So, and also you want to share it on the KNIME app. So how do you share it on the KNIME app? You simply, on the KNIME Explorer, you move it on your mount point, and then a web page will be created. And this particular component I'm showing here is something I reused in the visualization. If you remember these kind of charts, this is a component I found on the app, and I reuse it in my workflow. And this component is able to create a view using the library of Google GeoChart, right? And in fact, you can see inside that there is this JavaScript view in here. That's where the code is being used. But something else you would like to do is to use configuration nodes. Configuration nodes are the ones that you see here, and they can control which column is being filtered to be used in the visualization. So you add the configuration nodes, and once you click on the outside of the component, this is what it will look like. You will have those two drop downs, one with the country name and one with the numeric column that is the cases that we want to use. So this is a beautiful way to package nodes together to do custom visualizations, right? And something else that's important is the fact that that's, again, the configuration. But something else that is really important is those JavaScript, those components, when they have those widget nodes and those JavaScript views nodes, can create a dashboard, right? And that's the key part of what we use when you have all those multiple charts in the same visualization. So, for example, you can have inside a component a range slider, a parallel coordinates plot, a scatter plot, a bar chart, and when you package all those JavaScript and widget node together, you can then have a layout panel to decide how the final dashboard will look like. So a scatter plot on the side and a bar chart here, the parallel coordinates plot goes here, and here the range slider. And in the end, you will have that the component is creating a view with all those charts next to each other. This is particularly cool because automatically those charts will be able to communicate with each other. This means that, for example, the range slider will be able to publish a filter to the other charts, or like clicking on a pin of the bar chart, this will also enhance interactivity here. So, okay, so now you have all the key information to understand how component works. So I think it's now time to actually see the workflows in action. So let me now end the slides and open the workflow. So as you can see, this is the workflow. I recently re-executed, so we can see here, actually, let me re-execute the node again, and gone. So I can now execute the workflow, and we are getting from the API the latest data. And now we have here converting. You can see that node is now re-executing. If we open here, okay, so that's an interesting point. Right now, probably the developers of the API are doing some maintenance, right? So what then? Does our application break? No, because if we go inside this part here, you can see that in case there is an empty table, we are loading cache data. So each time we execute the node, we save the new data in a KNIME table within the workflow, and each time the API is now reliable, we use this table reader to retrieve this data that we saved. So that's something on how to make an application like this reliable. Then in this component here, we process the JSON. We process the JSON so that we start here from the cache data from the as an application, as a JSON, and from the output here using JSON nodes, we can see here the row numbers. So let me show here the time series table, and you can see that we have timestamps, the date, the name of the country, the type of data, even the latitude and the longitude, right? So if we go back here, we can see that we joined the data, this already showed. And finally, we can see here in the COVID-19 overview, a component. How do we open its visualization? We need to right click on the component, and then we select Interactive View COVID-19. When we do so, we are loading now, it takes some time depending on your system, we are loading this window. And in this window, we can see the first page of our application. So we can see the total number of confirmed. We can see the data is from still the 6th. So it's from yesterday, right? So even though the API is not working, we have decently updated data. And then we can then select here towards the end what we want to do next. For example, we want to select only data from Europe. So we select Europe here, and we are going to close and apply here our selection. So when we do this now re-execute with our selection, and then when we open the second node, we will see the visualization only for the Europe data. So now it's loading the visualization. And here we are. So focus on confirm on Europe. So here you don't have US, you have Spain, you have Italy, you have Germany. This is the bar chart that Rosaria showed you before. Then we have the line plot of the different countries. This is a bit more interesting when you use it on your KNIME because it's interactive. For example, if I want to look just at Spain, we just double click here on Spain and we can see Spain. We want to add Italy, we select and we just compare Italy and Spain. Here we have the logarithmic scale, and here at the bottom we have the shifted with a set of 20. And for example, we can focus only on Spain, Italy, and Germany, and we can see that there are similar trends once you shift those time series from the first day with at least 20 cases. If I scroll down, we can find here the Heatmap, which also we can scroll itself by seeing the full list. We can select here this tool to select which country we want to visualize. For example, we can select Spain here, and here at the bottom you see that we can see the total cases for Spain, we can select Italy, or we can select a number of them and then go through the latest values for each of those countries. Okay, so this is part of the interactivity of those combined views. And finally, we have the map on this latest data. So how did we create these views? If you see the first one, so I go in component and then open, I go inside and I can see that there are a number of manipulation nodes, some widget nodes, and also this line plot here, right? If you want to see how I created the layout, you need to click up here on Opens dialog to add the usage logic of component, right? So if you click up here, you can go in the visual layout and you will see all this layout that will make the dashboard with all those buttons at the bottom, right? And each node has its own configuration. For example, this line plot, if you double click, you can decide the x-axis, the y-axis, and so on and so forth. Something I also would like to show to you is the aspect of nested components. So if I go back and we go to the second component here, so I right-click COVID-19 focus, then I go on component and then open, you can see here is a bit more complicated since we are visualizing so many different things based on what the user selected. We are sorting the columns based on which country has most cases, and then we have two different dashboards. One if the data is normalized, not normalized, and one for the data that is normalized. Those two are components, and they are components within a components, so they are nested components. We activate the nested components that we want to open. So this will make the dashboard even more responsive to what you need to visualize. So again, we can then also get in this nested component, and we find here the line plot using the plotly node of the original data. Then this is the one on logarithmic scale with a math formula to apply the logarithmic transformation. We have here the Heatmap. We have here the map. This is the component I was showing you before that is available on the app. Then we have the bar chart that is the horizontal bar chart I was showing you before. And here is the line plot with loop nodes that will shift each time series given the onset on 20, right? Like if you check here, this is where we define what we want to select as an onset if we change this value. And also here we can see the layout, which make the dashboard I showed you before. Okay, so now you had an overview on how the workflow looks like. So let me now go back to the slides a second. But all of this works on the KNIME Analytics platform. What if you want to show this dashboard to someone that doesn't even want to interact with the workflow, to open the view of the components, to apply the settings of a component, then open the next component? So that's the idea, is to make this remotely accessible. So what you can do is to take the workflow that is stored locally on your open source KNIME Analytics platform and then move it on KNIME Server. And that's another software that KNIME produces. So KNIME Server is a way that where you can actually deploy your workflows there, and it can be on-prem or on a cloud solution. And then there you move the workflow there, and this will make it accessible via the KNIME web portal. And the KNIME web portal means that anyone with a link will be able to access this workflow. And the only thing they need is a web browser, right? So this makes things much more powerful if you need to have a dashboard available to anyone in your organization, despite whether they are using KNIME or not. So how does this look like? So let me open here this page. This is the link. So right now, I'm giving you a preview of the new web portal that we are developing at KNIME. So this is a link to access exactly this. So this maybe it's something that you add to a web page, or it's a link that you add to an email, and then people will need to log in. So really quickly, let me log in with my credentials. And hang on just a second. Let me get those right. And so now the workflows executes, and you can also see this loading, which is now executing all those different nodes within the workflow. And then we can see here the first page of the application. Let me go full screen. The first page of the application has the total number of confirmed cases to 1 million, and we can see then when I think now it's using cached data from the 2nd of April, maybe because still the application. So the cached data is given the time when I deploy this workflow, right? If I would have deployed it today when the API was, this would have been then updated. But really quickly, let's, for example, select again Europe, right? But this time let's select the normalization. So we see something different. So then I can click next, and then we are going to actually see the views, just that now we are normalizing. Again, the values are the number of people every 10,000 people, right? So those are the same charts as I showed you, but for example, we can compare Italy, Spain, Germany, and France. And we can see that in Spain, you have 24 people every 10,000 being confirmed cases. And we can also see the version where the data is shifted. So we can see that in this case, Germany and Italy, even after normalization on the population, they really are overlapping when those time series are shifted on the onset, with the first day with one case every 10,000 people. And then there is the map that is normalized, and we can see that, for example, Switzerland is has an high value, for example, compared to France. All right, so this is how the application looks like. I hope you enjoyed this preview of the new web portal. And let me go back to the slide a second. Those are the slides download you can find at this link. And then this workflow has been commented in this blog post that is on Towards Data Science on Medium. And once you download the slides, you will have this link to download and play and use the workflow yourself. This is also a thank you token for you. This is the download of KNIME Beginner Slack. You can go on knime.com/KNIMEpress and use this coupon to have a free download. And I think now it's time for the questions.
So there are some questions. There are 3 questions. I think the first one is for me. So the first one says, I'm interested to see how long it has taken for countries to start flattening of the curve after they implemented social distancing measures. So this part, the flattening of the curve, you see in the line plot of the absolute numbers, the total numbers of confirmed cases. So if everything goes well, you see that at the beginning the curve grows, and then the social distance measures are implemented, and then after some time you would see the flattening of the curve. So that's what you see in the China curve, and that's what you see in the South Korea curve. China implemented the social distance measure, the containment measures at the end of January, and you can see I think around mid-February that the flattening of the curve starts. South Korea, something similar. I think they have implemented the 20th of February, I think, and then so the flattening of the curve starts beginning of March. So it's around 2 weeks. Of course, it depends how strongly the containment measures are implemented. It depends on the health care system of the country. It depends on the number of people. So it's not that these 2 weeks are 2 weeks for everybody. So in Italy, they have been implemented March 9th. So they've been implemented at the beginning, but in a milder form. And then March 9th, and at the moment they see a not growing number of daily cases, but the flattening of the curve does not appear yet much. Yeah, I would say between 2 weeks and 3 weeks, depending on how they implemented the containment measures. Okay. So the next question is, do you report the last updated date for the data so that the user can see when cached data has been used? That's for you, Paolo, I think.
Yes, so I showed you briefly before in the dashboard, in the first page, when you open the view of the component, you can see at the top this date. And if the date is not yesterday, this means that currently the REST API is under maintenance for some reason. Today probably is what's happening. And so that's why you do not have the latest data. So I quickly showed you before. So just open the view of the component and look at the really top for the date.
And the last question, I think, if you want to answer that, is what you can use the KNIME Hub for, if you can use it for guided analytics. I think that's your answer.
Yes, no problem with that. So can we use KNIME Hub for guided analytics? No, the KNIME Hub, it's for sharing workflows or for saving on the cloud privately your workflows. Right now, you cannot execute the web portal from the KNIME app, and I'm not sure when this will happen, if in the future, but to deploy workflows with components and guide analytics, you need KNIME server. So in other words, you basically can use it to share your guide analytics workflow to the community, but not to execute it from the web portal.
So the KNIME Hub is a repository, and then the web portal is what you can use for the guided analytics. Yeah.
Yep.
Okay, so the last questions, I'll answer this one. So if we can add some forecast visualization using the time series functionalities of KNIME. I stayed away from that because if you want to make a mistake, the best way is to make a forecast. So I don't know, there are too many variables, and I didn't want to do a forecast of what's going to happen country by country. Of course, it's possible, right? You can take the time series analysis components, and then you can make a prediction. You can make it based on the past. You can build the past of the time series. And then country by country, you can make a prediction of, for example, when the flattening of the curve is starting. You have only, though, not that many examples, because you have to consider that now the pandemic is all over the world. But when we started checking what was happening, there was China, South Korea, and Italy. Those were the three countries where the epidemic was already going on. So there is a bit of lack of data. There is a bit of, they are not the same, right? They have different laws, they have different systems, they implemented different containment measures, they have different people. So it's hard to say that what happened in Korea is going to happen, for example, in Italy too, right? So I didn't do that. But in theory, it's possible, sure. When you have enough past, you can make a prediction based on what happened in Italy for, I don't know, what's going to happen in Switzerland or in the United States. Yes, that could be possible. Any more questions? Otherwise, we can close.
All right. If there are no other questions, again, you can find the workflow on the app, and the link to download the slides is the following. I'm still sharing a thing, right? tinyurl.com/covid-vis-9, and so you can find the slides there.
Thank you very much, and
thank you.
We'll meet again in one of the next webinars and workshop. Bye.
Bye.